Hello everyone, welcome to this video and my channel. If you are visiting first time to this channel, please subscribe my channel. Thank you. Let's start today's topic. In this video, we are going to learn about KNN, that is K nearest neighbor. So first we'll talk about how KNN works, what is the algorithm for KNN, and then we will try to implement KNN using Python. Okay, so let's go for KNN. So here you can see KNN. So K is basically a number. We'll talk about this. And NN means nearest neighbor. Okay. So let's go try to learn how this KNN algorithm work and the maths behind it. And then we implement KNN using Python. Okay. So please see this. Here you can see there are two shapes available in this graph. And suppose I have a third shape. Maybe this is the shape. Just I'm drawing here and I want to, predict this particular shape belongs to which group. Maybe this circle group or maybe this group. So we don't know. But I want to know this particular shape because there are only two shapes here. And I want to know for this data which belongs to which particular group. So the Canaan method is very, very simple here. Suppose I am taking k is 3. This is just a number and is nearest neighbor. So I'm trying to find the nearest neighbor from this particular data. So I'm able to find suppose maybe first one, then maybe second one this, and let's take third with this one. So I calculated three nearest distance from this particular shape, which I'm looking to predict this particular shape belongs to which group. So I just calculated the three nearest neighbors, and I find that in three there is two circle, right? There is two circle group and this group is only one item from this group. There are two item from the circle group. That's why because majority is the circle, so we can say this particular data, this particular fellow belong to circle group. This is actually the k nearest neighbor. So simple way to understand what you're trying to do. Just calculate the nearest neighbor and then we decide which is like which group is dominating in that neighbors. We said this particular data belong to that group, right? It means there is two things, three things we have to do. First, the number of k we have to identify, so we can change some number. So the first thing we have to select the number of k. Second is distance. We have to calculate distance because that's why we are only able to find the neighbors, right? So there are different distance formula, right? We have equilibrium distance and many different distance equation. And in this particular videos, I will explain which distance we can calculate for which type of data. And the third one is that is also important, finding the your nearest neighbor, right? Because you just first calculate the distance and then you have to find the neighbors. Here we have very less data, so we just draw the data and able to find which is our nearest neighbor. But suppose we have lakhs of lakhs data, that time you have to calculate distance from the particular point to each point, and then you have to find which are the nearest points, right? Suppose you are looking for five nearest data, so you have to find those nearest data, right? It means we have to search the neighbors, nearest neighbors. It means we have to find, like, if you go for sklearn documentation, you'll find there are different approach for searching method to to better search, right? So yeah, this is the k nearest neighbor approach. This is the k nearest neighbor algorithm where we have lots of data, and suppose for a particular data, if you want to predict this data belongs to which group, just calculate the distance from all the points, then find the nearest neighbors, and the number will be k. It will be decided by you, and after that you can just see, just check which is dominating, and then you can predict that one, right? If you see, let me explain you one real data. Here you can see we have data. So if you see, we have two features, feature 1, feature 2, and target. And in target only there are two class, 0 and 1, binary class. Maybe it's more than two classes, not a problem. Suppose I have a new data, right? Maybe I have a new data and feature 1 is maybe 4 and feature 2 is 5. And I want to check whether 4 and 5 belongs to 0 or 1 class. That time what I have to do, I have to calculate this distance from, like let me write here. So what I have to do, I have to calculate distance from this point to, like, from this point, then from this point to this point. So basically for each points, right? And then I have to find the minimum, nearest features, nearest points, okay, from this data. So just we have to all the distance. So we find the minimum distance, right? And then we can decide. Suppose I take k is equal to 5. So I will check the 5 neighbors. If there are 3 0, it means this belongs to 0 group. If there is 3 1, so that time is belong to 1 group. Maybe it's that possible all the 5 will be 0. That totally okay. The thing is, which is like dominating, we are going to predict that particular point from that class. Okay. So this is the basic algorithms for KNN. Now let's see how can implement KNN in Python, right? So here we got that there are three most important point. Number of neighbors we have to select. Distance, there are different distance method. So we can find which distance you are looking for, and then you have to search. Why search? Because there are lots of distance. So we have to find the minimum one, right? So that's why we have to search that. So if you go there, let me read the data. So I am using Google Colab here. So this is the data. I'm just reading this data. Here you can see that the same data. And if you plot this data looks like this anyway. So I want to make the KNN. I want to use KNN classifier for that. Okay, so that's very simple actually. So yeah, see, let me read the data again. So if you see this, we have target. So if you check, like we already knew here. So basically there are two group only, that is 0 and 1. One is very very important point here. See, because we are calculating distance, it's very very necessary that you have to normalize your data, right? But for the sake of example, I'm not normalizing here, I'm just using KNN. But anyway, if you are doing a real type work, definitely you have to normalize, because distance may impact by the the numbers, right? So if there is a outlier, definitely it will impact, right? Because it's a distance based model. So that's why it's very, very important to normalize our data. Okay, right? I'm not normalize this, but yeah, we have to take care. Now I'm just, splitting the data into feature and target, because that's very, very important for us whenever we have data. First we see, like here we have feature 1, feature 2, and target is Y. Now let me split the data. We already know why we need to split this. So I'm splitting this data. So this is my train and test. So I'm giving 20% to test and like 80% to training data. Okay. Now you see, this is the data only. So you can see I'm using here KNN classifier. This is the basically, if you go here and write sklearn, just let me write like this, KNN. So yeah, here you can see this documentation. If you check this, so we have neighbor weighted. You can give the uniforms, no problem with it. Algorithm, right? Algorithm, I already told you we have to search the minimum. That's a minimum nearest neighbor, so we need that. And the third one is metric, the distance metric, which distance metric you are going to use, right? So there are different distance here, right? We have like equilibrium distance, Minkowski distance. So there are different distance here. I already told you. So let me just a minute. If you check here, I already explained here. So I will share this notebook. You can go through this. See. So see, we have equilibrium distance, Manhattan distance, right? Cosine similarity, Hamming distance. Custom distance means we can create our own distance. Basically, why? Because sometimes we want like maybe weighted distance. Let me explain you why weighted distance. Suppose if you see the distance equation, normal equilibrium distance equation. So equilibrium distance equation looks like this. Y2 minus y1 whole square plus x2 minus x1 whole square. Suppose this is a two feature only in that case. But suppose I want to give more weight to this, because here is taking, uniform both. So, but suppose I want to give more weight to that. In that case, I can do like this. Maybe I can multiply with some number here. Maybe I can multiply with 0.75, and then I multiply with 0.25. So basically, I'm giving more weight to this, right? So we can create our own custom equation as well. Okay. So there I have like equivalent distance, Manhattan distance, cosine similarity, Hamming distance, custom distance. Custom is basically we can create our own. Now let's come here again. So basically we have the this particular KNN classifier. So just from SQL we can import this. Here you can see I'm just trying to import this. So let me copy this one, this particular. Okay, so just let me, yeah, here you can see I like just commented this, but in real case, we only want to, scale that, normalize that data. Why? Because we are using distance here. Anyway, so let me import this KNN classifier. So here I'm importing from sklearn.neighbor import KNN classifier. This is basically from here. And now let me make the model. So I'm making KNN classifier, giving neighbors is equal to 5. That totally depends on us. We can change this, right? P is equal to 2 means I am going to use equivalent distance. Here you already see is there, right? Default 2 is the equivalent distance. We can change 1, 2 also. So that is totally in our hand. Algorithm, see, I just told you, once we calculate the distance, we have to find the nearest neighbor. So there are different approach. The best way is auto also. If you don't give any distance, it will automatically select that right one, right? If you see here, see, this is auto. So if you don't give any particular algorithm, it will automatically take the best one, right? This is the auto. Otherwise, you can use ball tree, KD tree. Basically, this is just this algorithms try to find the nearest neighbor. Okay. In my coming videos, I will explain how this different algorithm will work, right? So even that's not needed to know in much detail. If you don't know, that's totally okay. Most of the people even don't know. Right, but yeah, if you use auto, it will automatically select. But if you want to do your own, you can select that one, and that totally, due to that, basically, you can reduce the time. If you select the best algorithm for your specific data, definitely you can reduce the time. Okay, time means the how much your model is taking time to train the data. That time you can definitely reduce this. Okay, so let me run this. So I'm just fitting the data, training the data. So here we can train the data, right? Now, if you want to predict something, let me predict some particular number. So if you already know this, if you check here, let me predict for a simple, if I already data dot head, and let me predict for a particular data. So yeah, you can see I'm predicting for this one. So this is basically zero class. Let me check this, it's working or not. Definitely it's working because it's already used in training data, so it has to work anyway. So yeah, we got this zero. If you want to check the score, here you can we check the score. So yeah, this score is 92%. Okay, anyway, right now I'm not trying to explain what is underfit, overfit. I will explain in coming videos what is underfitting, overfitting. That time I will again come to machine learning models and how can we, penalize our models and try to come out from overfit. That's totally separate story. But in this particular class, I want to explain you the how the KNN work. So yeah, this is the way actually KNN work. We have the data. There is challenge here, right? What is the disadvantage of a KNN? See, one you can say selecting K, yeah, it's also a challenge. But second challenge, very tough. See, each time if you want to predict for any data point, you have to do like a rerun everything. You have to calculate distance for each point. Again, you have to find the neighbor. Then you are going to predict. This is the first, like all the three steps you have to do for every time. Whenever you have a data you want to predict, you have to calculate the distance for each point. You have to find the nearest neighbors, and then you are going to predict. Right. So all the three things you have to do each time. This is the disadvantage of KNN. Otherwise, KNN is very good if you have a not a high volume of data. So that's definitely you can apply KNN. That's very good. Okay, but yeah. So yeah, I believe you guys are able to understand Canon because it's a very simple model. And my coming videos, I will try to explain different classification models, and then try to explain how overfit and underfit work. Thank you so much. If you are able to understand this, thank you. Please like this and subscribe my channel. Thank you so much.